So again, this is joint work with Bill Wedley, great co-author to work with. And this idea, this paper really originated from a challenge from Bill Wedley. We've been working on a different paper looking at some stuff with the geometric mean. And at one point he said, just start thinking about this. I want to see if we can explain a single, every entry in a single column of the supermatrix. And so we started talking about this and going back and forth, and I found some interesting things. And the kind of partial answer we're going to give today is that maybe we've been too hyper-focused about correctly capturing relationships between elements in pairwise ratio matrices, and that we need to give more attention, kind of move out now and also talk about clusters within a hierarchy, hierarchies in a supermatrix, and then the supermatrices, even like in complex models, like if it's a BOCR model or any of those. And a lot of this, again, we're going to focus around the unit. This is a quote from a paper by Wedley and Chu. And therein lies both the advantage and dilemma of AHP, and we're going to add here, and ANP. We do not need explicit knowledge of the underlying unit of a measure to derive a ratio scale, yet the derived scale has a unit. So again, we can make relative comparisons between objects. We don't need to know the underlying method, and that's the beauty, the advantage of AHP. But it also creates a dilemma because that unit in the derived scale is there, and we need to respect it, capture it, measure it accurately. So we're going to pay particular attention to units from derived scales. We're going to go kind of through the entire aggregation progress and look at what happens when we reweight the ratio vectors from the PRMs and link them together and think of this as the aggregation process as we go all the way through. So we're going to do something like Paul did, where we're going to take a known example. And in this case, we're going to look at Sadi's example of aggregating fruit across the different sizes and multiple magnitudes. And we're going to do this really for two reasons. We want to be able to validate our calculations against a known and true answer. And we're not going to introduce inconsistency or anything like that at this point, so that we can clearly explain the variations in this context. We're also going to use, again, this idea of the framework from AHP. If we can think of the column in a supermatrix as a hierarchy, it's going to help us understand the supermatrix better. And again, in this special case, we're going to look at how the units matter as you go through each step. So here's kind of the relationships that we've identified between the AHP and ANP. Again, if you look at the connections and how we connect clusters and elements, the process is the same there. There's some different effects on how we think of the arrows and the connections between AHP and ANP. Again, we're going to assume we get our local weights from the pairwise ratio matrix, and then those would be in the cluster levels of the hierarchy, where in the ANP, they're going to become the columns in the supermatrix. Then we have the issue about normalizing the unity. So again, we're thinking about how do the units between the vectors relate. And then when we go summing across clusters, we do it in equal levels in the hierarchy. We also have to think of that again as the clusters in the hierarchy, and then how the hierarchies relate through the supermatrix. This idea of global weights. So again, when we think of doing pairwise ratio matrices in the hierarchy, we're going to have these, and we've got our local weights, and then we've got a cluster above that becomes the parental global weight. This same idea can be applied to the ANP. And then when we look at the overall solution, you can say with the AHP that we're essentially summing and weighting. We can also use the supermatrix as we do in the ANP to get this stable result. You only have to generally raise that to the power of, to square it. And again, what's the total unit? This part about the unit is, again, so important. So let's go ahead and start looking at our example. So again, we're going to use the fruit. This is a common example from Dr. Sadi's work. And we've just come over here and essentially taken the ratios, and notice that everything here, so when he says 34.14, that these are expressed in the same unit. And in this case, in this example, it's a unit where this set of comparisons sums to unity is the unit. So again, we're going to look at how we can use those values. Again, we're just taking the data that Sadi provided, and we can express these in different units. So in this first column, if we just took the different clusters that like Sadi used, where we had a small fruit cluster, a medium fruit cluster, and a large fruit cluster, we can take those units, and we're going to convert them to the cherry tomato unit and use this unit here to get our supermatrix. I'd spend more time here, but let's talk about our model. So we have a big, small package, a variety package, a melon package. They have different amounts of the different fruits. So you can imagine, which one of these do I want to choose to give to a person? And we're going to, again, stay with size as the criteria here. So we take that scale with respect to the cherry tomato, and we convert all of these units into the same units, so they're cherry tomatoes, so that we can compare them. And so now, what if we think of this as a column, as a hierarchy? And again, then we can use this idea to aggregate clusters in each column. And again, this idea extends to the supermatrix. So again, we're going to think of aggregating the clusters in each hierarchy by column instead of by block. And we're going to aggregate the columns and hierarchies in the supermatrix. So in a general ANP supermatrix, the hierarchy or columns are equally weighted. Where maybe we want to think about weighting the columns, the hierarchies. And again, that would extend to a supermatrix. So we've got a couple of examples here. And the main thing I want to point out here is, again, we're going to look at these as almost like generic nodes. So when we get the Lime influence, we're going to think of this almost as a goal node per se in a hierarchy. And we're going to take the influence that the limes have in the network, and the same idea here for the packages. The variety package had small green tomatoes, limes, grapefruit, honeydew, and sugar watermelon. And again, if we look at the melon package, all we did here, again, thinking of a hierarchy, we didn't have these in clusters. Here we put them in the clusters that we used. Clusters, again, are just a convenience. So the image we provided in the paper emphasizes this, that clusters are a convenience, but if we think of these as hierarchies, these are really essentially the same type of hierarchy. We've just used the clusters.
Dr. Cooper, sorry for the interruption. You have a couple of minutes left.
Yep, yeah, so we have a couple of values here. And we're going to start with our unweighted supermatrix. Notice the different clusters sum to unity. So the question is, how are we going to get this column to sum to unity? And notice in this case that this cluster is all 0. So here again, we can go farther, and then we start thinking about how would we weight these hierarchies. So the first method is the typical ANP method, where we're going to get cluster weights by block. So we're going to block this whole cluster weight. And what we did there is we took all of the value, all of the cherry tomatoes that would have been in this cluster, all the cherry tomatoes, all of the cherry tomatoes, and we got our weights. So when we go and weight our unweighted supermatrix, we have a column now that doesn't sum to unity. In super decisions, what they do is they just renormalize this column again. So we get our weighted supermatrix now that sums to unity. Our method 2 that we propose is, again, is think of each of these columns as a hierarchy. So instead of getting a block weight for the cluster weights for every block, all 3 of the alternatives that were here, we're going to do each of these as if it was its own hierarchy. And in this case, we can see how the local weights and global weights idea translates through to give us this priority vector. So now we have a supermatrix that at the outset, this weighted supermatrix sums to unity. We raise these to powers. And again, with method 1, we get a set of weights. And with method 2, by individually considering each column as a hierarchy, you can see here that method 2 relates to the true priorities. And method 1, we're off a little bit. So in this sense, again, the generalization, we have the question here, do we care about the units in each hierarchy? So let me come to the observations. Raising the supermatrix to powers is a simple black box procedure. I hope the message I got across here is this is both the advantage and the dilemma of AHP and ANP. We don't need an explicit knowledge of the underlying unit of measure, but we have to pay attention to that unit. Again, maybe we focus too much on just the pairwise ratio matrix, and from this simple example, shown why we need to pay attention to the clusters and how we weight the clusters in the hierarchy. Are they equal or not? If we block and use the same weight across multiple columns, it's convenient. It reduces the number of comparisons, but it comes with a lack of precision. So again, by doing separate cluster weights for each hierarchy or column, we get weights that are more precise. Then we have to ask this question about the hierarchies in the supermatrix. Are the hierarchies within a supermatrix equally weighted or not? And then we can generalize that and take it one step further. And are we paying enough attention to considering the supermatrices in a complex decision? Are they equally weighted or not? So again, bottom line, the unit is so important. It's amazing this way that through relative comparisons, we don't actually have to measure it, but we need to pay more attention to it through the rest of the ANP, AHP process. Any questions?
Why do you consider Supermatrix is a black box? I think it is not really black box for me, because there are first, second, third degree influences, and that is the way we can capture it. Why do you think it is a black box procedure?
So, definitely to capture it. I agree completely with you there, Pearson, that it's a great way to capture it. But there's also some other ways that we could potentially aggregate those hierarchies or those columns. Potentially taking the geometric mean. Do we treat the columns of the weighted supermatrix as multiple hierarchies? So again, there's potentially other ways that we could aggregate those hierarchies. That again, are we saying, hey, the supermatrix is broken? No, it's one way, but there's potentially other ways that we could aggregate those hierarchies. And so that's part of where we're looking now.
I think that maybe by looking at, I don't know exactly how super decision does it, but in my when I first time I saw this approach with Tom, we never weighted the clusters equally. There was always, you had to find out whether the clusters, so what you are saying is correct. You have to find the proper weight to get to the right solution, right? That's exactly what it is. But if you weight them equally, you're close, but you're not exactly accurate, because, and I don't, personally, when I have used ANP models, and I have just wrote a paper recently on influence of the US in the world using ANP, we didn't weight the clusters equally. Now that's a difficult thing to do, because how do you know, what are the criteria to decide which one is more important, right? There's those comparisons, that's tough. And if you look at the paper on diagnostics in a long time ago about diagnostic with dependent symptoms, we discovered that we had to weight the clusters differently. That was very tough, because depending on how you weight it, the priorities that you get are a little different, and sometimes could be quite divergent.
Yeah, exactly. That's what we were hoping to show here is, again, doing exactly what you said, Luis, is you've got to do these cluster comparisons
right
for each column. And then
so
again,
it would be nice,
Orrin,
if you take this research and you tell us in the future how should you compare the clusters to help us do it the right way. Because when we have a solution, it's okay. But if you don't have a solution, you're estimating. And in that case, everything is the same, right?
Exactly.
So that's the reason why the easy answer was to make it all the same, because we don't know what the answer is anyway. So it's a little puzzling, isn't it?
Yeah. And I agree with Luis. I think it is hardly ever that these clusters are equally influential on the results. And in real life, we know that these clusters have different influence.
Right.
So different importance.
Yeah, and then
you're right, Orrin and Bill. You're right that they cannot be weighted equally. I agree with you. But the question is, how do you find in a situation where you do not know the numbers? How do you know what the priorities are? You have to guess it, so to speak. You have to estimate it yourself. But it's important to say they're not equally weighted. Maybe you should examine that question as opposed to assume it. Right? That's basically what my lesson is in this talk.
Yeah, exactly. And then think of that at the level of the hierarchies, the columns in the supermatrix, and then a step further, the supermatrices in a larger model, that we pay more attention to the units as we, in Bill's terminology, we link the clusters together in a hierarchy, we link the hierarchies in the network, and we link the supermatrices in a larger decision.
Right. Good. Well, we have 1 minute left according to my clock.
Any other questions right now?
Any other questions? Well, very nice. I thank you very much. Very interesting talks. Actually, we got the relationship between the first two speakers who maybe continue. So that will be interesting to see how they proceed. Looking forward to that relationship. And I'll see you shortly. I think there is a plenary at 10:05 from Alexio Ishikawa. So see you there.
That was going to be interesting. Yeah.
Thank you.
Thank you.
Thank you so much.
Bye.
Thank you.
Mhm.
Bye bye.
Bye-bye.
Bye.
Bye.
Bye bye.